Right, we've got S1 International Paper, June 2016. It's a normal distribution question. So it's on the old specification. So you wouldn't get 5 marks for doing this first part. So it's a bit different these days. But I think it sort of shows you how they might sort of lead you into answering a tricky question. Anyway, so 2016 question 7. S1 IAL. So the machine fills bottles with water. The volume of water delivered by the machine to the bottle is X, and X has got this normal distribution with a mean of 503 and a standard deviation of 1.6. So one of these bottles is selected at random. Probably the X is greater than 505. Well, here's the mean 503. So that area, steer the calculator, lower 505, upper a huge number, mean 503, standard deviation 1.6. You should get 0.10564. They'd be happy with 3 significant figures, I think. And then part II, it's in between 501 and 505. So lower 501, upper 505. Like I say, you wouldn't get 5 marks like these days because you're just sticking in the calculator. But they need to do this to sort of show you what to do for part B, really. So that area is 0.787. Don't forget that these 2 areas are going to be the same. So, to work out part II, you could just double this because it's the same as this, and then take it away from 1. So double that and take it away from 1, and that'll give you the area in between 501 and 505 because you're doubling that area. So that area and that area. And part B says find W such that 1006 minus W is less than X. So X is in between W and 1006 minus W. And you think, what's really going on here? Well, if you look at it, because the W's got to be bigger than this. This is the bigger one because X is in between them. Means 2 W's bigger than 1006. So W is bigger than 503. So it's over here. Or you could just look at the 0.9426 and think, right, well, W's got to be bigger than the mean. Oh, I couldn't have an area to the left of area in between these two of more than 0.5. And then, which means that the 1006 minus W, so this has got to be less than 503. That's going to be the left of the mean. Again, you could think about the 0.9426. So the 1006 minus W is over here. Now, if you work out W minus 503, the difference between these two, and then do the same with these two, 503 minus 1006 minus W, you get the same answer. So there's symmetry here. The W is as far above the 503 as the 1006 minus W is below it. And I think the reason they did this first part of the question is because they've given you a symmetrical one here as well. These two add up to 1006. Or if you like, the 501 is 1006, take away 505. It's right, funny way of putting it, but they're sort of telling you that this is symmetrical and they've sort of tried to show it you with this part of the question. And if it's symmetrical, of course, we can work out what each of these areas is. Now we want the value of W here. So the area to the left of W is this bit, which is just half of the 0.9426, which is the area in between. And then you've got to add this on, which is 0.5. And that gives you 0.9713. Do the inverse normal on the calculator with that area, and then the mean of 503, standard deviation 1.6, and you should get 506.04. Then the last part of the question, following adjustments, the volume of water is delivered by the machine to the bottle, such mu is 503, and we haven't got the standard deviation, so we're going to have to use a bit of maths. I have to use the Z values. So it's given that probably X less than R is 0.01, so R's over here, and the product that's less than it is 0.01. Probably X is greater than R plus 6 is 0.05. So that's the area, that bit there is 0.05, which means this R here has got a Z value of minus 2.3263. You can get that from the tables in the formula book or get it on the calculator with the 0, 1 normal distribution, the standardized normal. and this area is 0.05, and it's to the right, so it's a positive Z value, 1.6449. That means the R is 503 minus 2.3263 standard deviations, 2.3263 sigmas, which they're called Q, and the R plus 6 is the 503 plus 1.6449 standard deviations. So I've got two simultaneous equations with R and Q. If I do the bottom one, take away the top one, I'll lose the R's, and I'll just have 6 on the left-hand side. 503s will go, and then I'll have this. So I'll have 1.6449 plus 2.3263 all times by Q. Divide by this 3.97, I get Q is 1.51. Put that back into the first one, and that gives me the R is 4.995.